Welcome to today's video. Before beginning with the topic, I would like to tell you that I have created two playlists in the channel, one for biostatistics and one for biochemical calculations. The videos under the category biochemical calculations begin with the alphabet B followed by the number of the particular video. Under biochemical calculations, we are now going to see how the concentrations of solutions may be expressed. We are beginning with percent solutions in this video. Concentration of a solution refers to the amount of the solute dissolved in a given amount of solvent or in a given amount of solution. There are many ways to express concentration like percent solution, molarity, molality, normality, etc. And these terms are used preferentially in certain types of studies. For example, in volumetry, that is titration experiments, we generally use the expression normality. Molality is used in physical chemistry experiments. For preparing reagents for qualitative and quantitative analysis, generally the concentration may be given as percent solution. Out of these methods of expression, percent solution is comparatively the easiest, because if we have to prepare a solution of a particular compound, it is not even necessary for us to know the molecular weight of that compound. As the name itself indicates, percent solution is going to give us the amount or the volume of the solute in 100 gram of a solution or 100 ml of a solution. It is going to represent it for 100. And it is represented by the symbol which is the same as the percent symbol. The different expressions for percent concentrations are, it may be given as weight by volume percent, W by V or M by V percent, volume by volume, V by V percent, or weight by weight, W by W percent. So first we'll begin with weight by volume. Here the numerator stands for how we are going to take the solute. Here we are going to weigh the solute, and the denominator is regarding the solution. So we are going to measure the volume of the total solution. So 10% solution of a compound A, I have just put it as a compound A without naming the compound, because as we have seen earlier, irrespective of whatever be the compound, the method of preparation is going to remain the same. So W, so we are going to weigh 10 grams of the compound and add sufficient amount of the solvent so that the total volume of the solution becomes 100 ml. So 10% solution means 10 grams in 100 ml of the solution. 20% means 20 grams in 100 ml of the solution. Then this may be used when the solute is a solid, or at times even when the solute is a liquid. Volume by volume percent, V by V percent. That means you're going to measure the volume of the solute. So 5% solution of liquid A means 5 ml of liquid A and add sufficient amount of the solvent so that the total volume of the solution is 100 ml. So when it is 5 ml, we'll add 95 ml solvent so that the total volume is 100 ml. This will be used when the solute is a liquid. Weight by weight percent. You're going to weigh the solute and you're also going to weigh the solution. So 20% solution of compound B, that means 20 grams of the compound, add sufficient amount of the solvent so that the total weight of the solution is 100 grams. This may be used when the solute is a solid or even if it is a liquid. So this knowledge is sufficient for us to prepare any type of percent solution that is required, whatever be the method of expression. So weight by volume, 10% means 10 grams in 100 ml of the solution. Volume by volume, 5% means 5 ml of the solute in 100 ml of the solution. Weight by weight means suppose it is 20%, 20 grams of the solute in 100 grams of the solution. And we have to remember that percent solution, whether it is W by W or W by V, where we are weighing the solute, always it refers to the weight of the solute in grams, though it is not mentioned. If it is put as percent, it means it is the weight should be in grams. But nowadays we see sometimes terms like milligram percent used, where they want the solute to be weighed in milligrams. So if it is so, it has to be mentioned. If it is not mentioned, it is always the weight in grams. Now we'll see a few numerical problems, very simple problems based on percent solutions. They can be divided into three categories. The first one is they will give you the percent solution required and the weight of the solute also. We have to find out what should be the total volume of the solution in which it has to be dissolved. The second one, the percent solution concentration will be given. The total volume of the solution will be given. We have to find out how much should be weighed. So suppose a 2% boric acid solution is required, but a student has 6 grams of boric acid. So in how much volume of solution should she dissolve so that we get a 2% solution? So a 2% solution means 2 grams in 100 ml. That statement we have to write. Now we have 6 grams. So what should be the volume of the solution? That is X. So X is equal to 6 into 100 by 2, which is 300 ml. The other type, we have 5% solution required of sodium bromide. So we write the equation 5 grams in 100 ml is a 5% solution. The volume that is required is 200 ml. So how much should be weighed? So X will be 5 into 200 by 100, which is equal to 10 grams. The third type is they'll give the amount of the solute and the volume of the solution in which it is dissolved. We have to find out the percentage solution. So we have to just, whatever is given data, we have to write it. So 5 grams in 200 ml. And we all know that percent concentration means it is always in 100 ml or 100 grams. So here it is in 100 ml. What will be the amount of the solute that will be present? So X will be equal to 100 into 5 by 200. It is 2.5. So the concentration of the solution is 2.5%. So in our next video, we'll continue with the other measures of concentration. Thank you.